here we go. All right, so again, our title should be 6.5, divide monomials. And we are going to fill in this chart. So, we have all our different properties. And then I'm going to show you their expanded form, the rule, and the general rule. They're similar, you'll see. So, let's start filling it in. Where's my pen? There it is. Okay, so actually I want to let's give you the rules first, and then I'm going to, okay, we'll go this way. So the general rule for product properties, right, is, which one do I want to put it in? Yeah, this one. Okay, so if we have X A times, sorry, I'm looking at these other notes and they're not, when I printed them, they were kind of fuzzy, so just making sure I'm writing them right. Okay, so there's our general rule. So we have XA times XB, it would be XA plus B. Okay? So then we have, if we're doing this example right here, we would have x3 plus 4, which would give us x7. X to the 7, x raised to the, I never say it right. I'm sorry, I'll try my hardest to say it better. Now, if we want to do, we can solve it like that, right? We know it's 3 plus 4 gives us a 7, but we can write it out in expanded form. So if we have x to the third, that would simply look like 3 x's, right? We're multiplying, so I'm using the parentheses. Then we have 4 x's. And if we were to multiply that together, how many x's do we have? We have 7 total, right? So x to the 7. So 2 different ways you can do it. You're going to use the expanded form, I think, on a lot of problems in this assignment, just because it's a lot easier, because sometimes you're going to be dealing with a negative number. Okay, so there's the first one. Pop in any questions after each row if we have any. I want to try to get through this chart fairly quick so that I don't take up a ton of your time doing notes today.
The first part of this is just review, but I think it's gonna help you to see it all on one chart, so that you just have this to look back at, like when you're taking a test or a quiz. Yeah.
So I like this. This is important. So definitely write this down, guys. Okay, so let's look at this next one, the power property. I'm going to give you, there's your example, the x squared, and then all that raised to the third. So let's look at our general rule. We have x, a, b, and that would just mean we're going to do x and then a times b. Okay, now if we're doing our, I'm gonna go with expanded, then the rule for that. So this one first we'll do box, and then this box and this one. That's how we'll do all of them. So then let's look at this. So expanded form for this, if we were to write that out, we have x squared 3, wait, why did you write it out like that? Hold on. Oh, I see what you did. Okay. Sorry, Miss Myers helped me with notes because mine were funky. So first off, if we're doing x squared to the third power, or raised to the third, it's going to look like this. This was our expanded form. And then we can expand that a little more. So right here we have 2 x's, right? Because x squared is 2 x's. Same here. And same there. So then now we can just count all our x's. 1, 2, 3, 4, 5, 6, right? So x to the 6. Now that's if we were going to expand it. And expanding really is helpful, especially like I said, when you're going to get that negative number, and you'll see what I mean. When it's something like this, or not the negative when we get down here, then you may not need it as much, but it's just kind of nice to know. Alright, so then let's look at this rule with this example. We have x would be 2 times 3, right? If we're looking at the general rule over here, which would give us our x to the 6.
Now, the other thing with the expanded that I find is that sometimes, like, I might forget, like, what is the rule? And using the expanded form helps remind you of, oh, that's right, that's what that rule is. Because sometimes we forget, like, when do we add them, when do we multiply? But you can always go back to that expanded form that shows you what to do.
Okay. I was just adding my equal sign. You don't have to, but I like it there. All right, so let's look at the product to power property. So let's look at our general rule. We have x, y, with our raised to our, that's an a, sorry. So then we would just distribute that a through there. So we'd have x, a, y, a. So that's our general rule. Then let's look at our example here. We're going to write this out in our expanded form. We're going to have xy times xy times xy. Because it's raised to the third, right? Then, oh, yeah. Then we're going to have, if we expand it more, we're going to have our 3x's and we have our 3y's. So our answer would look like that. If that doesn't make sense, just let me know. We're just expanding everything out. So we first did our xy 3 times, then we separate our x's and our y's so we could get our answer. Okay, now let's look at, we have x, so if we have our original example over there, xy raised to the third, we would just simply do that because we have to distribute that 3 to each x and y. So I mean, yes, this is a lot quicker, but this helps with any kind of confusion also. So I like both ways. I think I prefer the expanded, then I know I'm not doing it wrong. I don't want to redo anything. Let's see. All right. Let's look at quotient to power. Let's look at our rule for quotient to power. So we have x a over xb, and normally we would just subtract our exponents. Okay, so let's look at this. Let's look at, this is where I like the expanded better on the, when we're getting like the fraction looking ones. I like them better here. You'll see why. So we have, oh, did I write that down? Oh, there it is. Sorry. Oh, did I put the wrong one? No, where's this one? Got my notes all confused. Here we go. Sorry. I wrote down the wrong rule over here, you guys. I was looking at the wrong one. I apologize. Let me change this. Don't get mad at me. I'm sorry. I thought it didn't make sense when I wrote it. I looked over there. I was on the wrong page of my draft notes. Okay. Okay. We'll go back and write the rule after my whiteout dries. So let's look at our expanded form of this. So if we have x raised to the 6th power, that is 6 of our x's, right? Okay. Over y to the 6th. Okay. And then all that is, oh, I'm going to run out of room. I'm going to squeeze her over here. We can't really do anything other than just write it like that. We can't cross any of those out. We can't, you'll see what I mean by cross out in the next one. So that's it written out. Expanded form. And then that would just be our answer if it was asking us for that. So, okay, is this dry yet? Okay, I think I'm dry. So our rule, x over y, ooh, to the a. Oh, I hope that's dry. And we're just basically distributing that a through each one. So I'm going to put a little sideways so my whiteout looks funny right now. There we go. There's the rule for the general rule. Okay, now using this example over here, we have our x over y raised to the 6th power. We are just, like I said, distributing that x to each different term there. So it would be x 6 over y 6. Just like we got here, just a little quicker, right? Okay, let's do this one. Okay, let's look at quotient property when we're working with the larger numerator. This is where I really like the expanding. Okay, so let's look at it. We have our rule. Let's look at our rule first. That was the one I wrote accidentally, so we're going to go to this one. XA over XB. And this is where we would subtract our exponents. Okay. So let me show you the expanded form. In this we have x to the 5th power, right? So we're going to write out x 5 times. Okay? We're going to leave it in our little fraction form, and we're going to put our x to the 3rd. Okay? You want to kind of line them up. It makes it easier when you cross them out, but okay. So then, all we do, these two cancel, that set cancels, and that set cancels, right? So we're left with x to the 2nd power. That's why I like those. Those are super easy for me to eliminate them. I don't have to even think. Okay, so let's look at our rule. It is simply just x 5 minus 3. And like I said, there's more work for the expanded one there, but when you get to this next one where we're going to do a larger denominator, you're going to see why I like the expanded form better. Okay. Alright, so let's look at the next one. So I'm just setting my timer. It's telling me to eat, but I can't eat yet. So okay, so let's look at this guy. So what's that? Who's talking?
For the rule, is that 5 minus 3 or is that times 3?
5 minus 3.
Okay, I was making sure because I can barely see.
Okay, yeah, sorry. I had to zoom my thing up so you guys could see the whole thing.
It's okay, my Wi-Fi is just like glitchy.
Yes, the lovely Wi-Fi. Alright, so let's look at this one. Let's look at our general rule for quotient property when we have a larger denominator. So if we do use our same rule up here, we're going to subtract 3 minus 6 and we're going to get a negative number. So that's why I think you'll like that expanded form when I show you. Okay, so let's look at our general rule. And that one is xc over, oh, that's a c. Sorry, that kind of came out funky. xc xd. That's what that is. Okay. Okay, so there's our general rule. So it would be xc over xd equals 1 over xd minus c. Okay, now let's look at this in the expanded form. Okay, so we have 3 x's, x times x over 6 x's. Okay, so there's our little fraction. We're going to get rid of these guys, which would leave us nothing up top, but we have to, right? We have to put our 1 up top because we don't have anything up there. And then we're left with 3 of our x's, so x cubed. So if we didn't do the expanded form, it's going to look kind of funny over here because you're going to be left with that negative number. If you did it like this, you'd be left with x to negative 3, but you can't have a negative. So that's why I like this when you see that you're going to be dealing with a negative number especially. So let's write out our little rule over here. So you need to know when you see that, it's got to stay on the bottom because we can't have... And I wrote that down wrong originally, didn't I? 1 over x 3. Oops. This should be a 3. Sorry. Sorry, that one's a 3. I wrote a 2. Sorry. So 1 over x 6 minus 3 would give us 1 over x to the 3rd. Okay, last one. And this is the 0 exponent. I don't know why, but I hate the 0 exponent, but I hope you like it more than me. Okay. So let's look at our rule, our general rule. Just something
it's
you kind of...
my favorite. Once you
see, I guess.
It's like, oh yeah, x to the 0. He
yes.
knows all the time.
And I think it is once you know that, but if you don't, then I'm like, well, how am I going to tell him this without, you know what I mean? That's what I don't like about it.
Right.
But your chart was great, so thank you again for the chart. I love this. Okay, so our general rule, x to the 0 is going to equal 1. Okay? So if we look at our example over here, x to the 3rd over x to the 3rd, let's expand it. Okay? And cross out our little pair. Whoops, that meant to go right through it, and it did not went on the side. You know what I mean. There. We're left with nothing, right? We're left with a 0. Or what our 0 would be x to the 0, right? But we all know, if we look at our rule, that's really 1. So that's going to equal a 1.
Wait. It wouldn't equal 0 there. It would just be...
Well, wouldn't it be... Oh, so like you wouldn't write a 0, you just...
They become a 1 as they cross
Okay,
off.
so you don't even need to... Okay, got it. So you're just going to automatically put a 1. I put 0 because like I'm looking at it going, oh, I'm left with 0, nothing. But it's really 1. We refer to our rule, it's really 1. Kind of wrote that out of habit, I think.
Well, it's not... Because, like, whenever you have, like, x over x, or, like, 5 over 5, when you cross them off, they're both divisible by 5, so it changes to a 1, not to a 0.
Okay. All right, and then if we look at our rule, if we're going to use x, it would be 3 minus 3, which would be x to the 0, which 1 is our answer, right? So I feel like if you know your rule, x, anything to the 0, okay, you know you're getting the 1, it's fine. On this one, I don't like the expanded because obviously you see I wanted to automatically put that 0 there. I just kind of remember x 0 to the 0 power of 1. Okay, guys? Does that make sense? I hope I didn't confuse you with anything.
So with this one, what I like to see there is it's the expanded form shows you why x to the 0 equals 1. So, because both that second and third column, we have to get the same answers for x to the 0, whether we're doing expanded or whether we're using our rule.
Mm-hmm.
And so that second and third column, maybe Mrs. Dodson, can you kind of put an arrow between the two of them?
So like these two?
Yeah, like from the 1 to the x to the 0.
Oh, I see what you're... Oh, okay.
This one's a little different in, like...
So you want me to... I hope I do this right.
I think I put it on my notes.
Oh, okay, the same way. Oh, but you have it between these two.
Yeah, that's what I mean.
Oh, I thought you meant these two. Sorry.
Okay.
I see what you mean.
So see, the second column came out to 1, and the other one came out to x to the 0. But both of those have to be the same value, the same number. They're just written differently.
Okay.
So that's why x to the 0 is equal to 1.
Like that, right?
Yeah.
Okay. Okay. Got it. Over 6 to the 3rd. So looking back at your chart, looking at our rules, someone tell me what you think we should put here. I'm just curious if you remember. I like these ones. These ones to me are easy peasy. So I'm going to start writing it out in expanded form. Get a lot of 6s. 9, 10, 11. Okay, so if we write it out in our expanded form, which I think I would do first, we're going to get rid of our pairs there, and we're left with what, guys? 6 to the what? 8, right? And if we didn't do expanded form and we just did our rule, it would be 6 raised to the 11 minus 3, which still would give us the same thing, right? And like I said, I think I just like that expanded form, especially when I know I'm dealing with a negative number. I think otherwise the rules are pretty good. But you do what's easy for you. All right, let's look at this one. So just by looking at it, we can see we have a larger denominator. So we're going to be dealing with that negative. So that's kind of where that expanded form is going to come in handy, I think. So we're going to write our 1, 8, because we only have 1, right? We don't have any power up there. We know it's a 1. Then we're going to have 8 times 8 times 8. We can get rid of that 1 pair. And then we know that we have to have our 1 on top. And then these are on the bottom, right? And I believe in your answers, it's going to want you to do 8 times 8 times 8. So it would be 1 over 502 if we did that. 512, sorry. Make sense on that one, guys? So put it in. Make sure if you are left with the 8 cubed or 2 squared, whatever you have, that you're going to get it without the exponent for your answer. Oh, and guys, if you can have your cameras on during this time, that'd be great. I totally forgot to ask you. Sorry. All right. Do I need to wait? Are we ready to move on?
Can you please wait?
Yep. You understand it, though, right, Madison? You're just writing it down?
Yeah.
Okay. Okay, can you stop hitting me? Jeez. This child's going to kill me. Alright. Try that. Shh. Shut him up. Okay. Alright, let's look at something like this. Alright. So remember, this is the one I don't like, but you guys might like it since it seems fairly easy after you get the rule. Okay, so let's look at this. 7a to raised to the 0 plus 8x raised to the 0. So we're going to write this out in our expanded form. We have our 7, and we know that a to the 0 is 1, right? So there's our 1. And then we have 8, and again, x raised to the 0, so that's a 1. And then we can, 7 times 1 is 7, right? 8 times 1 is 8, so we're just going to add that up, and we should get 15. Any questions on that one? No, we're good, we're good? Okay. All right, let's look at this guy. Okay, so we're going to do our expanded form. So, remember our rule. Look at your chart if you need to. We have y, and we have that 3. We're going to times the 2. Okay, so right like that so far. Times our y, and then 5 times the 2. Okay, so it's going to look like that on top. Our y, the 6, we're not doing anything to him. We're just going to write him in there. And so now, y, and then 3 times 2 gives us 6. Times y, and then 5 times 2 is 10. And then that's all over our y6. I'm going to squeeze mine here. So then now, we add the exponents there. So we're going to get y over, or y raised to the 16 over y to the 6. And now we're moving on to that our other rule where we just subtract those, because we need to simplify this down as low as we can. So y to the 10. And if you want to even write that expanded where you do the y 16 times over y 6 times, you'll still get your y over 10. But I would only do that prior for that one if you know you're going to be dealing with that negative. So there's your answer for that one. Okay, any questions on that one? I think I only have like one or two more because they look kind of scary, so I just kind of wanted to go over them with you. This guy, two more, that's it. Okay. Alright, so let's look and see what we got here. We got 16x to the 5th power times 10x divided by 20x raised to the 4th power. Alright. So let's look at what we got here. We know, first off, we can do our multiplying of our 16 and our 10, right? And that's going to give us 160. Okay. Now we can deal with our... Oh, and I have the division because that we have our sign there, so that's our division sign. I'm dealing with these two right here to get the numbers on the top of that fraction, okay? So now we have x raised to the 5th times x. And we just add those exponents, right? If you look at our rule, you'll see we're going to add those exponents. So that's going to be that on our top. 160x raised to the 6th power. Now we can, I have my division line for our division there, and now we can work with this guy. And there's not really much we can do, right? There's nothing out here. We don't have to change anything, so he's just going to go.
Can you explain that again? Because I'm so lost.
Okay, so this is a division problem, right? We have our division sign. I'm dealing with this first section here on this side of that equation, I guess we want to call that. And so we do 16 times 10, which gives us our 160. Then we can do our exponents, and our rule is when they're like this, we just add them. There's, remember that imaginary 1 there? So we're just doing 5 plus 1, and that's where we got the x raised to the 6th power.
Okay, thank you.
And then that one stays the same because there's nothing we can do to it right now. So now we can reduce some stuff here. So if we do 160 divided by 20, I always work with those numbers first. I like to get that out of the way. That's just going to give us 8. And now our rule, we have a bigger numerator, so we can just do 8 with x 6 minus 4, right? Which then would give us 8x squared. Any questions? Does that make sense? So all that craziness turned into that. Had negatives. I know sometimes negatives can be freaky too. Alright, so let's look at this. Let's first do the numbers. So negative 72 divided by negative 6, and we get a 12. Okay? So we're done with that part. That gives us 12. But you can see our numerator here is bigger than our denominator is bigger than our numerator, so that's going to be a negative number. So you can do your expanded form with the w's, which I like to do with my negatives, just to remind myself that that 1 goes on top. 7, 8, and then 13. Whoa, that's a funky line, sorry. 1, 2. Woo, barely fit that. Okay, and then you can get rid of your pairs. All right, they're going to cancel themselves out. So we have that 1 on top. And we're left with 1, 2, 3, 4, 5. So that would be our... Oh, actually, we're not done yet. I forgot my W. W to the 5th. Sorry. Okay. But I noticed in the answers, when you guys go put this in, you can't like put it in like that. It wants you. And I don't know, Miss Myers, if there's a better way to explain this. But you're going to multiply that 12 times the 1 and have the 12 on top, and then your W5 is on the bottom. But is there a better way to explain that, Miss Myers? You're muted.
So when I do the 12, there it's, if you have negative 72 divided by negative 6, it's just a 12, which is going to be in the numerator. Got it.
So you would just do that there and not do that step.
Right. And okay. Then those W's end up in the denominator.
Okay. So guys, that's easier. I figured there was a better way. So then instead of doing it that way, because it showed those steps when I looked at the examples, so just you do the division right here, negative 72 divided by negative 6, you get your 12, that's on top. Then we work with our W's, and since that's a negative that we're dealing with, it goes on the bottom. Make sense? Any questions, I should say? Let me know. Tell me, people. Because that's all I got for